How a gecko can climb straight up a wall?
We notice something very strange.
Or what makes a cockroach so fast?
This is the American cockroach, the cockroach you think you don't have in your kitchen.
What if we could actually harness nature's secrets to create remarkable new inventions? Insect-based robots, armies of artificial ants.
Everybody seemed to be playing well.
Or even spider silk made by goats.
What we are looking for is something that nobody has ever seen before or ever understood before.
Scientists are just beginning to reap the benefits of using nature's way to solve problems.
But you want to get up near the fence line.
For 3.5 billion years, animals like this wallaby have been evolving amazing ways to get around.
They get really good fuel economy at high speeds of movement, which is counter to what we know from automobiles and what we know about ourselves when we run.
The secrets of how animals move and behave are being studied by scientists around the world. One of the most prominent is biologist and author Edward Wilson.
To open up one of these ant colonies, as I have done, is very much like looking at the operations of a Swiss watch. Nature has done it better than anything we have heretofore achieved or even imagined.
In the lab, nature's extraordinary machines are being analyzed and put to work by biologists like Robert Fole.
Here's one. We look at nature and try to find the general principles by which nature does extraordinary things that we haven't done, figure out what those are, and then use those in combination with the engineering we can do to make something perhaps even better than what we see in nature.
Fole has studied the motion patterns of dozens of unusual animals, like the millipede.
They have two legs that are sort of connected together, and a wave passes along the body. When I first looked at a cockroach running on a treadmill, I saw what most people saw. Lots of legs moving very rapidly, and it looked quite difficult to understand. But now when I look at it, I literally see a pogo stick. In our study of a diversity of animals with different leg numbers and different skeletons, we found something that was extraordinary. We found that all-legged animals, when they run, push on the ground in the same way.
As an animal's legs bounce up and down, they store and release energy just like a pogo stick.
These animals do the same thing. They produce the same kind of forces on the ground as a pogo stick or as you. It's just they're using three legs together as one. Three of the legs work kind of like a stool. Two on one side and the middle on the other. So you sort of have two sets of stools, sort of a very stable configuration, one after the other.
The payoff for all this research, an astonishing collection of bio-inspired robots. The hope is to use these robots someday to do anything from cleaning your house to building a space station.
When you see these flexible kinds of limbs and the behavior of the robots where they're bouncing, very much like what we see in the animals, it starts to activate in you the feeling that these robots are alive.
Want a robot to climb the side of a building? Model it on the gecko.
This is a tokay gecko, and this is actually a pretty big one. They live in tropical regions and like to eat crickets, or that's what we feed them downstairs.
We began to look carefully at their legs and their feet, and we noticed something very strange, and that is their toes can actually uncurl and peel. Kind of like a party favor when you blow it out and then you let it curl back. We looked more carefully and found that their feet have toes with pads on them, with little leaf-like structures. And those little leaf-like structures have little serrations in where you can see that they have hairs, a huge number of hairs. And if you take one of those hairs and look at them, the hairs have split ends. They can have 100 to 1,000 nano-sized split ends. And then we wondered, well, how do they stick? There was only one answer, and that it was van der Waals forces.
Van der Waals forces are the attractions that occur between individual atoms. These forces are quite small, but when multiplied by the billions of atoms on a gecko's foot, they can become very strong.
we'd like to be able to synthesize the hairs. It looks very possible to make those kinds of structures through human technology.
One of your belts? That's good.